what is recursion? Well, first off, what is a recursive function? Well, what is a function? Well, a function, right, it's something which takes a value and it transforms that value in some way and then returns a result. Okay, let's have a look at some examples. The first example can be the increment function. So this function takes an integer and adds 1 to it. That's all it does. So its type definition, which is this line here, says it takes an integer and returns an integer. And then in the function definition, this is the input x, and then the output is x plus 1. So in this case, right, it takes the value x, which is an integer, and then it transforms x by adding 1 to it, and then the result it returns is x plus 1, right? So I can quickly just show you. If I have inc 5 and I enter, it gives me 6, and if I have inc 0, it gives me 1, right? That's how the increment function works. Let's have a look at add. This is another example. What add does is it takes its input value is a pair of integers and its output value is an integer, right? You can see this in the type definition. It takes a pair of integers and it returns an integer. Great. So if you look at the definition, what it does is it says we have x and y and we want to add x and y. So it takes x and y as a pair of integers, x and y are taken as a single value and then later decomposed, rather than if it was a code function, and I have a video on code functions if you're interested, that'll be linked in the description. But it takes a single value and it decomposes them. If it was a code function, then it would take one value at a time, essentially. But I go more into that in my video in the description on code functions. So it transforms it by adding the first and second elements of the pair together and then returns that result. Finally, let's have a look at a bit of a different function. This is the length function. What is the length function? Well, it takes a list of anything and returns how many items are in that list. You may not have seen this A syntax before. This is called parametric polymorphism, or just polymorphism in Haskell, right? I have a video on that, which I'll link below, but essentially what it means is it can work for any data type of inputs. And so, like I said earlier when I said it can take a list of anything, it doesn't matter what the data type of the list is. Now, this is a recursive function, which is what I'll be explaining what recursion is later, so I won't go too into depth in this, but essentially, if it's an empty list, you say it's 0, and if it's not an empty list, the length of a list with, say, 10 elements is the same as the length of a list with 9 elements plus 1, and then you go again, and you say, well, the length of a list with 9 elements is the same as the length of a list of 8 elements plus 1. So the length of a list with 10 elements is the same as 1 plus 1 plus the length of the list of 8 elements, and you keep going until you get to the length of an empty list, which you say is 0. And I'll explain this more later, but I hope that gives you the general idea of what we're looking at. So it takes a list of anything, this function, it transforms it by calculating how many items are in it, and then it returns that result. So then, what is recursion? Well, a function is recursive if it refers to itself in its own definition. Now you can have recursive types and recursive type definitions, but I'll do a later video on that at some point, and I'll link that in the description once I've done that. But with recursive functions specifically, right, it refers to itself in its own type definition. So, in its own function definition, right? So this is the type definition. It takes an integer and it returns an empty tuple. An empty tuple in Haskell is sort of like, it's analogous to, void or other things in other programming languages. It essentially means it returns nothing. So what does this call me function do? Well, it just recurses however many times the number you pass to it is. So if you pass call me 5, it will recurse 5 times. So essentially what it does is it follows this recursive pattern where it's got a base case, so a stopping condition, and it's also got the recursive case. So what does it do? Well, it takes an integer and it doesn't return anything. And like I said, the tuples just mean void or nothing. So what does the first line do? Well, the first line defines the function's type, and like I've said, a function is a mapping from input to output values. Therefore, its type would make sense to be a mapping from its input values type to its output values type. In this case, its input values type is integer, and its output values type is an empty tuple, which means nothing. The second line is the halting condition or the stopping condition. and it ensures that the function is only called n times. So if you do call me 5, it makes sure that the function is only called 5 times. Because if we didn't have this, it would go call me 0, call me -1, call me -2, and so on and so on, and it would just use up all your computer's memory, which would be fun. And then finally, the third line is the recursive definition. It says that, you know, calling me n times is the same as calling the call me n-1 times, because you've used up one call, and then you're figuring out how many times to call next with the n-1. So essentially, calling me 5 times is the same as calling call me 4 times, because you've called once by calling the call me 4 times, and then the call me 4 times will then figure out how many more times to call itself. So it uses pattern matching, right? It matches when it's 0, and it matches when it's anything else, right? That's an interesting thing to talk about. I have a pattern matching video, which I'll link in the description below as well. But essentially, what's important for recursive definitions is that what you need to know about pattern matching for this video is that patterns are matched in order, and the base case should always be matched before the recursive case, because the recursive case would always be matched, right? So if you think about it, n is just a general number, while 0 is a specific number. 0 is the base case, right? If you are matching 0 before any other number, that's fine, because it'll go, well, is it 0? No. Is it some other number? Yes. Okay, we recurse. If it's matching the recursive case first, it will never hit the base case, because the base case is just a specific case of the recursive case, right? So if you're saying, well, I can match any number, okay, is it 1? Yeah, I can match that. Is it 0? Yeah, I can match that. But then it would never match the actual 0. So I'll show you what I mean. So if we had it like this, what we would do, right, if we had call me 3, it would go call me 2. Okay, call me 3, match it here, right? Then it will do call me 2, match it here. Call me 1, match it here. Call me 0, match it here. Call me -1, match it here. Call me -2, match it here. Call me -3, match it here. And it'll just keep going forever, right? However, if we had it this way, because they're matched in order, right? If we had call me 3, it wouldn't match it here, but it would match it here. Call me 2 wouldn't match it here, but it would match it here. Call me 1 wouldn't match it here, but it would match it here. And then finally call me 0, it would match it here, and not bother with that case. That's essentially why it's important to have the base case first. Okay, and this basically prevents infinite recursion, which isn't what we want. Okay, brilliant. So let's have a quick look at some more examples in Haskell. So let's have a look at the factorial function. If you're not aware of a factorial function, it's essentially the factorial of a number is the number times every number before it. So 5 factorial is 5 times 4 times 3 times 2 times 1. And, you know, 3 factorial is 5 times 3 times 1. Sorry, 3 times 2 times 1. My mistake. And then I'll give another example so it's clear. 4 factorial is 4 times 3 times 2 times 1, right? But what you might be able to figure out is that 4 factorial is 4 times 3 factorial, and 5 factorial is 5 times 4 factorial, which is really useful because that's basically a recursive definition, right? So factorial, the factorial function, what we can do is it takes an integer, returns an integer, that's its input. It transforms that integer by timesing it by all the integers before that integer in order, right, from biggest to smallest. And the recursive the base case is 0, because 0 factorial, and this is defined in maths, 0 factorial is just equal to 1. I won't get into why that's the case, because I don't fully understand it myself. But I'll link a video, there's a good video I watched a while ago, I'll link that. Factorial of n is just the same as n times factorial of n minus 1. So 5 factorial is 5 times 4 factorial, right? And I can run this, if you just give me a second. So here's the example, right? And if I just show you this. Fab, okay. So if I do factorial, and I've got this little asterisk here, because I believe there's a function in the standard library called Factorial or something, but it wouldn't work otherwise. It could just be Factorial x, right? But I put an asterisk, so it's still more readable. But it's Factorial prime, Factorial asterisk, or not asterisk, quote, essentially. So Factorial 5, right? 120. If I do Factorial 2, yes, Factorial quote 2 is 2, Factorial quote 3 is 6, right, because it's 3 times 2 factorial, Factorial 4 is 24 because it's 4 times 6, because it's 4 times 3 factorial, and that's essentially what it is, right? So that's really good. And then finally we'll do the length function, right? This is the function that we're coming back to now. What the length is, right, is it takes a list of anything, like I said, returns the length of that list, and I'll explain how this works. So let's just look at some examples quickly. So if I do length of 1 dot dot 5, should give me 5. If I do 1 dot dot 7, should give me 7. And what 1 dot dot means is just generate a list from 1 to 7. So I'll show you what that means. So if I do 1 dot dot 5 and I run that, it gives me a list of 1 to 5. And if I do 1 dot dot 7, it gives me a list of 1 to 7. And if I say do like 0 dot dot 7, it should do 0 to 7. If I do minus 5 dot dot 7, it should be minus 5 to 7. So it works. It works like that, essentially. Hopefully that makes sense. So I'll explain this definition now. So what it does is it says the length of the list with 3 items is the same as the length of the list with 2 items plus 1. Because what it will do is it will do pattern matching, and it will match the list as the first item and the rest of the list. So it will discard the first item and then just match the rest of the list, which is really useful. This colon here is called the cons operator, and I'll be doing a video on that soon. So what it does is it says, how do I write this out? I'll just write this out as, so what it does is it says the length of 1, 2, 3 is the same as 1 plus the length of 2, 3, which is the same as 1 plus the length of just 3, which is the same as 1 plus the length of just the empty list. And what we say here now, because this is matched first, it will say, oh, the empty list, that's matched first, right? This matches an empty list, this matches a non-empty list, because even the non-empty list of just 3 in a list by itself, that's matched as 3 plus the empty list, so that would be matched as 3 and then just the empty list like that. That's how it's matched, right? So then once it reaches the empty list, it will then go, okay, great, well that's the base case, so then that's 1 plus 1 plus 1 plus, and then the length of 0, we say that's 0. The length of an empty list is 0, right, because there's nothing in that list. So then that then goes to 1 plus 1 plus, and you can see it's a bit of repetition, right, but it goes to 1, and then that goes to 1 plus 2, and then that goes to, well, 1 plus 2, which is 3. Is essentially how it works, and that's how it's evaluated. That's how it works recursively. That's everything for the video. Thank you very much for watching.